Good morning, everyone. Okay, this is homework number 95, example number 9, finding the volume when we're not revolving about an axis. There are four examples with different axes of revolution. So let's look at part A. We're given the curve y equals x squared, that parabola, and we're also given the line y equals 4x. So you could tell this is the parabola and that's the line 4x. For part A, we are rotating about y equal negative 2. Horizontal, y equal negative 2 is this horizontal line down here. Things that we should know. Because this is a horizontal line, the axis of revolution is horizontal. I will be in the x. Everything has to be in the x's. So if you don't have it in terms of x, well, let's go back and fix that. Now, definitely when I rotate this region here, down here, I'm not going to draw it because it's going to get kind of messy. It will be a washer. There's going to be this big gap in the middle, this big hole in the middle. And because it's a washer, I need to deal with two radii. I need to figure out the big R and the little r. So the big R is axis of revolution to that curve out there, to the curve that's furthest away. The curve that's furthest away is that one right there, which is the line. And so this is what we're going to consider big R. Big R is the distance from there to here. And whenever we're looking for a total distance, vertical distance here, I'm going to get the top and I'm going to subtract the bottom. I need to do top minus the bottom. So big R from the top to that bottom. So big R will be 4x, that's the top, minus the bottom is this. And remember what this was over here. The axis of revolution was negative 2. So when we ask you for the big R, we're going to say it's 4x plus 2. It's a binomial. We have to be careful when we write the integral. That is the big R. Little r goes to the first curve. Axis of revolution to that first curve right there. I'm going to call that little r. And so little r, maybe I should write it over here. I need to do top minus the bottom. That top piece is the parabola minus the bottom is the axis of revolution, which means that little r would be x squared plus 2. So it is a horizontal axis of revolution. I need to be in the x. The big R is from the outside curve to the axis. 4x minus a negative 2. Little r is from the axis of revolution to that first curve, which is the top, minus the bottom. X squared minus a negative 2. And that's little r. So when I set up my integral, volume will equal to pi integral. Now remember that we are in x's in dx. So the limits are going to go from 0. I go to the x's over here. That point right there where they met was 4. So part A, I'm going from 0 to 4. The big R squared minus the little r and square that. So look at the way I set it up. Pi, big R, second power, little r, second power. Make sure you agree. Pause it, verify it. Now, algebraically, it will get messy. You have to square that. You have to square that. You're going to combine like terms. You're going to work it all out. Well, combine like terms integrate, top minus the bottom. And if you do that, you're going to end up with that. 896 over 5 times pi. Now, here the biggest thing is the setup. What I want you to do in the calculator is I'm going to enter that 4x plus 2, that was the big R, x squared plus 2, that was the little r. And so when I do that, when I go to math 9 is the integral. Let me kind of start again. I want to get that pi in there first. So let me go second pi. And then I'll do math 9. I'm going to go from 0 to 4. The big R, I put it in y1. So let me get my y1 and square it. And I'm subtract. My little r, I put in y2, but I got to square that. And so I'll verify that. That's where I put the big R, and that's where I put the little r. And that'll be my answer. That's a decimal. So let me write it over here. 562.973. So if we divide that out, it should be equal to that. I'm going to move on. Part B. Part B, I'm revolving about y equals 16. That is up here, y equals 16. Things to note. It is horizontal. Because it's horizontal, I will be in dx. So keep that in mind. I need to find big R and little r. Big R is the distance from the axis of revolution to the outside curve. So I'm going to go to here. This is big R. And to figure out big R, I have to do the top minus the bottom. The top was 16. Remember, that was the axis up there. Minus the curve. Little r is from the axis to that curve. So little r, can I squeeze it in here? Is 16 minus 4x. Big R, and that's little r. Top minus the bottom. Top minus the bottom. Everything in x's. Everything. So when I set up my integral, volume equal pi, the limits are in x's. We're still going from 0 to 4, same as part A, because we're in x's. The big R squared, little r, and square that. So again, I would have to multiply out that binomial, subtract, combine like terms, then integrate it, and then multiply with pi. And so the volume here would end up being 1024 over 5 times pi. For this homework, big thing is the setup. Can you set that up? Big R, little r. And because the axis of revolution is not on an axis, we have these binomials here that we have to be careful with. I'm going to show you part C and part D, because now, where to go? Okay. Now our axis of revolution is vertical line. That is a vertical line x equal to -2. So I guess if I extend this out a little bit over here, well, I don't want to go too far here. So I'm going to pretend that is x equal -2 at -2. And because I have a vertical axis of revolution, I need to be in dy. Because it's vertical, I'm in dy. And because I need to be in y, the parabola that I had y equal x squared, I need to solve that. I don't know, I think I'm getting a little glare. So if I solve that, I get x to equal square root of y. The other equation was y equal 4x. I need to solve, so I'm going to get x to equal y over 4. Y over 4. So keep that in mind. I solve because I need to be in dy. And now when I find the radius, I'm going this way. So big R is to there. Remember, I had to solve, so that one is really x equal rad y. And so when I calculate the big radius, big R, I have to go right minus the left. Right minus left. Right minus the left. And this left, this axis of revolution was a -2. And when I calculate little r, I go to this curve. And so little r would be the right, which we had to solve. It was y over 4 minus a -2. So that is big R and that is little r. And when I write down my integral, remember I'm in y now. So the limits, I have to look at the limits in terms of y. And the limits in terms of y, I'm going from 0 to where they meet here, and they meet at 16. Big R, second power. Little r, second power. And I'm in dy. Make sure you do the setup. That's the big thing here. Make sure you're able to set it up. Next one, last one. Part C, part D. The axis of revolution is at x equal 6. So let me put it over here somewhere. A vertical axis of revolution. I'm rotating about the line x equal to 6 over here. Because it is a vertical axis of revolution, I need to be in dy. Keep that in mind, in dy. So the big radius now, I'm going from here to that. That's the one that's further away. Now the one that's further away is that y over 4. So big R then, the right-hand side minus the left-hand side. That is the big radius. The little radius, let me go up here somewhere, is from there to, too far, to there, to that first curve. So little r will be the right minus the left. Right minus the left. Big R and then little r. So let me show you my setup over here. Volume is equal to pi integral from 0 to 16, because I'm in terms of y. The big R, second power, little r, second power, dy. If you're able to set it up, that's big. Make sure you're looking at the radius. Normally in class, because this kind of gets messy, I will just pop it into my calculator. So pop that into your calculator, set it up. I am doing calculations right now, and I'm getting 268.083. Okay, this is homework 95.